Hello dear students, in this video I'll continue with solving the sample paper for CBSE Class 12 Applied Mathematics. In my previous videos, I have solved the sections A, B and C of the same sample paper for the session 2023-24. In this video, we will see the solutions to sections D and E of the sample paper. So here we have section D. This section comprises of long answer type questions of 5 marks each. Here we have the 32nd question. On doing the proofreading of a book, on an average, 4 errors in 10 pages were detected. Using Poisson's distribution, find the, this is not probability of, find the number of pages. Find the number of pages with no error and 1 error. Find the number of pages with no error and 1 error in 1000 pages of first printed edition of the book. Given e raised to minus 0.4 is 0.6703. So here we can see that for Poisson distribution, the parameter is lambda, that is the mean. Here the mean is given as 4 errors in 10 pages. So let us take the random variable x as number of errors in one page, and then the average is given, that is lambda. It is 4 by 10, which is 0.4. So here we can see that the random variable x follows Poisson distribution with parameter lambda, and we have lambda as equal to 0.4. So let us write the distribution. Probability of x is equal to k. This is equal to e raised to minus lambda raised to k upon k factorial. Now since we know lambda, it is 0.4. So this is e raised to minus 0.4 into 0.4 raised to k upon k factorial. E raised to 0.4, e raised to minus 0.4, the value is given here. So it is 0.6703 into 0.4 whole raised to k upon k factorial. So this is the Poisson distribution. 0.4 whole raised to k. So the number of pages with these k errors in 1000 pages, it is given by 1000 into this. So this is equal to 1000 into e raised to minus 0.4, 0.4 raised to k upon k factorial. So this is 1000 into 0.6703 into 0.4 whole raised to k upon k factorial. So now we have a relation for the number of errors, number of pages with k errors in 1000 pages. So now we can find the number of pages with no error and number of pages with 1 error in 1000 pages. So number of pages with no error in 1000 pages will be, here we will have k as 0. So this is equal to 1000 into e raised to minus 0.4, 0.4 whole raised to 0 upon 0 factorial. This is nothing but 1000 into 0.6703 into 1. So this is 670.3. So this is equal to 670.3. And next we have number of pages with 1 error in 1000 pages. Here we have k as equal to 1. So this is equal to 1000 into e raised to minus 0.4, 0.4 whole raised to 1 upon 1 factorial. So this is 1000 into 0.6703 into 0.4. So this, when we simplify, we get it as 268.12. So here we have these many pages with no error, 670, approximately 670 pages with no error, and approximately 268 pages with 1 error in 1000 pages. So here writing the distribution carries 1 mark, and then writing this relation carries half mark. Then the first subdivision carries 1.5 marks, and the second subdivision carries 2 marks. So a total of 5 marks for this question. Moving on to the or part of the same question. How many times Sunil toss a fair coin so that the probability of getting at least one head is more than 90%? So here this is a question from the handbook itself. So we are familiar with the steps and the solution. So let the number of trials be n, and then let us take the random variable x. It denotes the number of heads obtained in n trials. So here we can see that x follows binomial distribution with parameters n and p. So here p, the probability of success is probability of getting a head. So probability of getting a head p, this is equal to half, and q is probability of failure. So it is probability of getting a tail, which is also equal to half. So the distribution is given by probability of x is equal to r. This is equal to NCR, then p power r, q power n minus r. Or it is NCR half raised to r, half raised to n minus r. So this is the distribution, the binomial distribution which this random variable x follows. And now let us see what is given. Here it is given probability of getting at least one head is more than 90%. So probability of getting at least one head means probability of x greater than or equal to 1. This is more than 90%. So probability of getting at least one head is probability of x greater than or equal to 1. Since it is difficult to find 1, 2, 3 up to etc., we do not know what is n. So let us write this as probability of x greater than or equal to 1 is 1 minus probability of x less than 1. This is greater than 90% is 90 by 100. Now probability of x less than 1 is probability of x is equal to 0. This implies 1 minus probability of x is equal to 0. This is greater than 9 by 10. Now here we have the distribution probability of x is equal to r is given by NCR half raised to r half raised to n minus r. We need probability of x equal to 0. So let us put r as 0 here. This implies 1 minus NC0 half raised to 0 into half raised to n minus 0, which is n. This is greater than 9 minus 10. So here this is 1, this is 1. So 1 minus half raised to n is greater than 9 by 10. Now let us transpose half raised to n to the other side and 9 by 10 to the left hand side. So from this we get 1 minus 9 by 10 greater than half raised to n. Or we have 1 by 10 greater than half raised to n. Now this half raised to n, it is nothing but 1 by 2 raised to n, because 1 raised to n is 1 only. So we have 1 by 10 greater than 1 by 2 raised to n. So if we cross multiply, we will get 2 raised to n greater than 10. Now let us substitute values for n such that 2 raised to n is greater than 10. So if let us do it in the rough. When we put n as 1, we will have 2 raised to 1. This is not greater than 10. When we put n as 2, we have 2 square. It is 4. This is also not greater than 10. When we put n as 3, we get 2 cube. This is 8. This is also not greater than 10. When we put n as 4, we have 2 raised to 4, which is 16. This is greater than 10. So here we can see that if we put n as 4 or any number more than 4, we will get 2 raised to n as greater than 10. So from this we get n greater than or equal to 4. Therefore, number of times Sunil should toss a fair coin so that he will get at least one head. That probability is more than 90% is 4 times. So if he tosses the coin 4 or more times, then he may get at least one head. That is probability of getting at least one head. It is more than 90%. Therefore, n is 4 or more times. So, this is the answer. So, here writing what is given 1 minus probability of x equal to 0 greater than 9 by 10 up to this step carries 1 mark, and then writing the distribution and then getting a relation for 2 raised to n up to this step carries 2 mark, and then finding the value of n and all these steps carries 2 marks. So, a total of 5 marks for this question. Moving on to the next question. This is a question on LPP. A manufacturer has 3 machines, 1, 2 and 3 installed in his factory. Machines 1 and 2 are capable of being operated for at most 12 hours, whereas machine 3 must be operated for at least 5 hours a day. He produces only 2 items M and N, each requiring the use of all the 3 machines. The number of hours required for producing 1 unit of M and N on 3 machines are given in the following table. So, here we have this table, and then the 2 items M and N, the time each item required on each of these machines. It is given here in hours. He makes a profit of rupees 600 and rupees 400 on 1 unit of items M and N respectively. Formulate the above problem as LPP and solve it graphically to find how many units of each item be produced to maximize the profit. Also find the maximum profit. So, here we can see that there are 3 machines 1, 2 and 3, and then machines 1 and 2 it is capable of being operated for at most 12 hours. So, machines 1 and 2 it can be operated for at most 12 hours. So, this is less than or equal to 12. And then machine 3 it must be operated for at least 5 hours. So, machine 3 it should be operated for more than or equal to 5 hours. So, using this information we can write the constraints, and here we have the objective function. He makes a profit of rupees 600 and rupees 400 on 1 unit of items M and N respectively. So, using this we can write the objective function, and using this table and these constraints we can write the subjective constraints, and then we can formulate this LPP and solve it graphically. So, let us take, let x and y be the number of units of items M and N respectively. So, first let us write the objective function. The objective function is to maximize the profit. So, we have to find the number of units of each item that should be produced to maximize the profit. So, maximize Z is equal to, he makes a profit of rupees 600 on 1 unit of M. So, on x units of M, he will make a profit of 600x. And then he makes a profit of rupees 400 on 1 unit of N. So, for y units of N, the profit is 400y. So, maximize Z is equal to 600x plus 400y, subject to the constraints. The first constraint is with respect to machine 1. So, here M requires 1 hour and N requires 2 hours on machine 1, and machine 1 should be operated for at most 12 hours. So, subject to x plus 2y less than or equal to 12. And next we have the next constraint with respect to machine 2. M requires 2 hours on machine 2 and N requires 1 hour on machine 2. Machine 2 can also be operated for only at most 12 hours. So, here again it is 2x plus y less than or equal to 12. And next we have machine 3. Machine 3, here M requires 1 hour and N requires 1.25 hours on machine 3, but machine 3 should be operated for at least 5 hours. So, it is more than or equal to 5. Let me write it here. X plus 1.25y greater than or equal to 5. Now, this 1.25 it is nothing but 125 by 100. So, if we simplify this using 5 tables, it is 5 by 4. So x plus 5 by 4y greater than or equal to 5. Or here you get 4x plus 5y by 4 greater than or equal to 5. Or 4x plus 5y greater than or equal to 20. So this is the first constraint. This is the second constraint. This is the third constraint. And then we have the non-negative constraints x comma y greater than or equal to 0. So this is the non-negative constraints. And now moving on to solving this using a graph. So whatever we have just now found, I have written it here. So we have to maximize z is equal to 600x plus 400y subject to x plus 2y less than or equal to 12, 2x plus y less than or equal to 12, 4x plus 5y greater than or equal to 20, and x comma y greater than or equal to 0. So using all these, let us solve this graphically. First, let us draw the line corresponding to x plus 2y equal to 12. So when x is 0, y is 12 by 2, 6, and when y is 0, x is 12. So the first point is, let us take the graph sheet. This is OX, OY. Let us mark the points as 2, 4, 6, 8, etc. 10, 12, etc. And here also 2, 4, 6, 8, 10, 12. So 0, 6 is somewhere here and 12, 0 is somewhere here. Now let us draw a line joining these 2 points to get the line x plus 2y equal to 12. So this is the line x plus 2y equal to 12. And next we have the next constraint. Let us draw the line corresponding to this constraint. Next we have 2x plus y equal to 12. Here when x is 0, y is 12, and then when y is 0, x is 2x is equal to 12. So x is 12 by 2, which is 6. So the first point is 0, 12, it is somewhere here, and next point is 6, 0 here. So if we draw a line joining these 2 points, we will get the line corresponding to 2x plus y equal to 12. This is 2x plus y equal to 12. And next we have the next line, 4x plus 5y equal to 20. 4x plus 5y equal to 20. When x is 0, this becomes 0. So 5y equal to 20, y is equal to 20 by 5, which is 4. And then when y is 0, this part becomes 0. This becomes 0. 4x plus 0 equal to 20. So x is equal to 20 by 4, which is 5. So the points are 0, 4 and 5, 0. So this is 0, 4 and 5, 0 is somewhere here. Let us draw a line joining these 2 points to get 4x plus 5y equal to 20. Now if we see the first constraint, it is x plus 2y less than or equal to 12. So x plus 2y less than or equal to 12, it is towards the origin because the origin satisfies this inequality. So it is this part. And next we have the next constraint, 2x plus y less than or equal to 12. It is again towards the origin. So it is this part. Next we have the next constraint, 4x plus 5y greater than or equal to 20. So if we substitute the origin and check 0, 0, origin does not lie on this inequality. So it is the other side, that is this part. And next we have the non-negative constraints x, y greater than or equal to 0. So it is the first quadrant. So the feasible region is, it is this part. So this is the feasible region. Now let us mark the corner points of the feasible region. Here let us mark this corner point A 5, 0, then B 6, 0, and this is C, and here it is D 0, 6 and E 0, 4. Now here we can see that C is the point of intersection of these two lines, x plus 2y equal to 12 and 2x plus y equal to 12. If we draw this on the graph, we will directly get the coordinates of C as 4, 4, or even otherwise we can get the coordinates by solving the first two equations. So if we multiply this equation by 2, 2x plus 4y equal to 24. And here this equation is 2x plus y equal to 12. When we solve these two, 4y minus y, this is 0, plus 3y equal to 24 minus 12 is 12. So here y is 4. When we put y as 4 here, we will get 2x plus 4 equal to 12. 2x is equal to 12 minus 4, which is 8. X is 4. So the coordinates of C are 4, 4. So here we can see that the feasible region is bounded, and we have also got the coordinates of the corner points. So by the known theorem, the maximum value of z will occur at one of the corner points. Let us see on which corner point the maximum value of z lies. So here the feasible region A, B, C, D, E is bounded. Now let us draw a table like this. So let us find the value of z at each of the corner points. So the corner points are A 5, 0, then B 6, 0, then C 4, 4, D 0, 6 and E 0, 4. So when x is 5 and y is 0, 600 into 5, z is 3000. Then when x is 6 and y is 0, 600 into 6, 3600. And the next point is C 4, 4. When x is 4 and y is 4, z is 600 into 4 plus 400 into 4. So it is 2400 plus 1600, which is 4000. And then for D 0, 6, x is 0, y is 6. So 0 plus 400 into 6 is 2400. And then for E 0, 4, x is 0, y is 4. 400 into 4 is 1600. Among all these, we can see that 4000 is the maximum value. So this is maximum. So we have found the maximum profit is 4000 and it occurs when x is equal to 4 and y equal to 4. Here x is nothing but number of units of m and y is nothing but number of units of n. So when 4 units of m and 4 units of n are produced, maximum profit will be obtained and it is rupees 4000. Hence maximum profit is rupees 4000 when 4 units of each item m and n are produced. So this is a question for 5 marks. Writing the objective function carries 1 mark. Writing the constraints carries 1.5 marks. Graph carries 1.5 marks. The remaining steps and the final answer carries 1 mark. Now moving on to the next question. A company produces a certain commodity with rupees 2400 fixed cost. The variable cost is estimated to be 25% of the total revenue received on selling the product at a rate of rupees 8 per unit. Find the following. You have to find the cost function, revenue function, break-even point and the profit function. We are given the fixed cost and then the variable cost is estimated as 25% of total revenue. And then the selling price per unit is rupees 8. All these are given. So let us find each of these. So let us take, let x units of the product be produced and sold. As selling price of 1 unit is rupees 8, total revenue on x units will be 8 into x. First we have the cost function. The cost function is given by sum of fixed cost and variable cost. So it is fixed cost plus variable cost. Fixed cost is given as 2400 plus variable cost is given as 25% of total revenue. So total revenue is 8x plus 25 by 100 into 8. So this is 1 by 4. Sorry, x is there. So this is 2400 plus 2x. This is the cost function C of x. Next we have the revenue function. Revenue function we already found. Revenue function, it is nothing but it is 8x. Revenue function R of x is equal to 8x. And next we have to find the break-even point. Now we know that at the break-even point, total cost is equal to total revenue. So at the break-even point, we have C of x equal to R of x. So this implies 2400 plus 2x equal to 8x, or 2400 equal to 8x minus 2x, which is 6x. Therefore, x is equal to 2400 divided by 6. It is 400. So break-even point is 400 units. And next we have the profit function. The profit function P of x, it is given by the difference between the revenue function and the cost function. So revenue function, it is 8x minus cost function is 2400 plus 2x. So it is 8x minus 2400 minus 2x. So this is 6x minus 2400. So these are the various functions. So here finding the cost function carries 1.5 marks. Finding the revenue function carries 1 mark. Finding the break-even point carries 1.5 marks. And then the profit function carries 1 mark. A total of 5 marks for this question. Moving on to the OR part of the same question. The production manager of a company plans to include 180 square centimeter of actual printed matter in each page of a book under production. Each page should have a 2.5 centimeter wide margin along the top and bottom and 2 centimeter wide margin along the sides. What are the most economical dimensions of each printed page? So here we can see that the production manager plans to include 180 square centimeter of actual printed matter. So the area of the printed matter should be 180 square centimeter, and then each page should have a 2.5 centimeter wide margin along top and bottom and 2 centimeter wide margin along the sides. We have to find the most economical dimensions of each printed page. So here let us take, let x and y be the dimensions of the printed pages. So if we take x and y as the dimension of the printed page, let us consider this is the printed page, that is the inside box. So let us consider this as x and this as y. Here it is given the area of the printed matter is 180 square centimeter. So x into y will be 180. So from this let us take y as 180 by x. And now they have said each page should have 2.5 centimeter wide margin along the top and bottom. So this is 2.5 centimeter and this is 2.5 centimeter. And then it should have 2 centimeter wide margin along the sides. So this is 2 centimeter and this is 2 centimeter. So if we consider this whole page, this whole length will be x plus 2 plus 2. So it is x plus 4. And then this whole breadth, it will be y plus 2.5 plus 2.5. So this whole thing, it will be y plus 5. So this whole part will be y plus 5. As a result, the area of this entire page, it will be length into breadth. So x plus 4 into y plus 5. So this let us multiply. It is xy plus 4y plus 5x plus 20. Xy we already know it is 180 plus 4 into y is 180 by x plus 4 into 180 by x plus 5x plus 20. So this is equal to 200 plus 5x plus 4 into 180 is 720 divided by x. So this is the area of the page. We have to find the most economical dimension of each printed page. So we have to find the values of x and y such that area will be minimum. In other words, we have to find the points of local minima. So for most economical dimensions, first let us find the critical points. dA by dx equal to 0. So if we differentiate this, we will get derivative of 5x is 5 and then derivative of 1 by x is minus 1 by x square. So 5 minus 720 by x square equal to 0. So from this we get 5 is equal to 720 by x square or x square equal to 720 upon 5. So this is 144. From this we get x is equal to plus or minus 12. Since this is length, we cannot have negative 12. Therefore, x is equal to 12. Now to find the point of local minima, the second derivative, that is d square a by dx square. This should be more than 0. So d square a by dx square at x is equal to 12, it is equal to. So here if we find the derivative of this, it is minus of 720 into minus 2 by x cube. So this is greater than 0. Let me write one more step. So this is equal to 1440 upon x cube. This is greater than 0 at x is equal to 12. So this is greater than 0. As a result, x is equal to 12 is a point of local minima. Now we have to find the most economical dimensions of each printed page. As a result, here we have the length as 12 plus 4, which is 16. And then we have to find y. Y is nothing but 180 upon x. Y is equal to 180 by 12. So this is equal to 15. Hence, the most economical dimensions are 12 plus 4 equal to 16 and 15 plus 5 equal to 20 centimeter. So these are the most economical dimensions. So here all these steps and finding the value of x up to this step carries 2.5 marks, and then the remaining steps and the final answer carries 2.5 marks. A total of 5 marks for this question. This is the last question in this section, section D. The management committee of a welfare club decided to award some of its members. Say X for sincerity, some say Y for helping others selflessly, and some others say Z for effective management. The sum of all the awardees is 12. Then 3 times the sum of all awardees for helping others selflessly and effective management added to 2 times number of awardees for sincerity is 33. If the sum of the number of awardees for sincerity and effective management is twice the number of awardees for helping others, Use matrix method to find the number of awardees of each category. So this is solving system of linear equations in 3 variables using matrix method. So here they have given we are taking the members for sincerity as X, members for helping others selflessly as Y, and members for effective management as Z. The first thing is sum of all the awardees is 12. So that is the first equation. So here X plus Y plus Z, this is equal to 12. And then 3 times the sum of awardees for helping others selflessly. Helping others selflessly is Y and effective management is Z. Added to 2 times the number of awardees for sincerity. This is X. This is 33. So the second constraint is 3 times Y plus Z plus 2x equal to 33. Let us rewrite this. So 2x plus 3y plus 3z equal to 33. So the second equation is 2x plus 3y plus 3z. This is equal to 33. And next we have the next equation. Next equation is if the sum of number of awardees for sincerity, this is X, and effective management, this is Z, is twice the number of awardees for helping others, this is Y. So the sum of number of awardees for X plus Z, this is equal to 2Y. So the next equation is X minus 2Y plus Z equal to 0. So these are the 3 equations. Now let us solve these 3 equations using matrix method. The given system of equations can be expressed in matrix form as 1, 1, 1, 2, 3, 3, 1, minus 2, 1 into the variable matrix X, Y, Z. This is equal to the constant 12, 33, 0. That is AX equal to B, where A equal to the coefficient matrix 1, 1, 1, 2, 3, 3, 1, minus 2, 1. And then X is the variable matrix X, Y, Z. And B equal to 12, 33, 0. So let us take this as 1. Now Ax equal to B implies X equal to A inverse into B. For that we have to find A inverse. So to find inverse of matrix A, first let us check whether inverse exists or not. So for that we have to find determinant of A. Determinant of A is 1 into 3 plus 6, then minus 1 into 2 minus 3, plus 1 into minus 4 minus 3. So this is 9 plus 1 minus 7, which is 3, not equal to 0. So this implies A inverse exists. So to find A inverse, we have to find adjoint of A. So for that, let us find the cofactors of each of these elements. A11 will be leaving first row, first column. So it is 3 plus 6. 3 plus 6 equal to 9. Then A12 leaving first row, second column, negative of 2 minus 3. So it is plus 1. Then A13 will be leaving first row, third column. It is minus 4 minus 3, minus 7. Next we have the cofactor of next element, that is element in the second row, first column. A21, it is minus of 1 plus 2. which is minus 3. Then A22, leaving second row, second column, it is 1 minus 1, which is 0. Then A23, leaving second row, third column, minus of minus 2, minus 1, minus 2, minus 1. So it is minus of minus 3 plus 3. Then A31, it is leaving third row, first column, 3 minus 3, which is 0. Then A32, it is minus of, leaving third row, second column, 3 minus 2, so it is minus 1. And next, the last cofactor of the last element, A33. It is positive 3 minus 2, which is 1. Now, adjoint of A is the transpose of the cofactor matrix. So, adjoint of A, it is transpose of this matrix, 9, 1, minus 7, minus 3, 0, 3, 0, minus 1, 1, the whole transpose. So, it is 9, 1, minus 7, minus 3, 0, 3, then 0, minus 1, 1. This is adjoint of A. Now, we know that A inverse is equal to 1 by determinant of A into adjoint of A. Now, from here, from 1 we have x is equal to, and then also from 1 x is equal to A inverse into B. So, from this we can find x, y and z. X is the variable matrix x, y, z. This is equal to A inverse is 1 by determinant of A. Determinant of A is 3. So, 1 by 3 into adjoint of A is this matrix. 9 minus 3, 0, 1, 0, minus 1, minus 7, 3, 1 into B. B is this matrix. 12, 33, 0. So, this is 1 by 3 into 9 into 12 minus 3 into 33. So, it is 108 minus 99. Then 12 plus 0 plus 0, and then minus 7 into 12 minus 84 plus 99 plus 0. So, this is equal to 1 by 3 into 108 minus 99 is 9, and then 12 minus 84 plus 99 is 15. When we divide each of these by 3, we will get 3, 4 and 5. So, the first row corresponds to x, second row to y and third row to z. Therefore, x equal to 3, y equal to 4 and z equal to 5. So, these are the values of x, y and z. Now, here writing the given system of equation in matrix form carries 1 mark, and then finding determinant of A carries half mark, and then finding adjoint of A carries 2.5 marks, and then remaining steps and the final answer. All these carries 1 mark. A total of 5 marks for this question. Moving on to the next question. These are source based questions of 4 mark each. The first case study is pipes and cistern. Here the mark allocation is given here. It is 2 plus 1 plus 1. A, B and C are 3 pipes connected to a tank. A and B together fill the tank in 6 hours. B and C together fill the tank in 10 hours. A and C together fill the tank in 7.5 hours. Based on the above information, we have to answer these questions. So, we have to find in how much time will A, B and C fill the tank. So, here we can see that the first question carries 2 marks. So, let us solve each of these separately. Now, here it is given A and B together fill the tank in 6 hours. So A plus B fill the tank in 6 hours. As a result, A plus B is 1 hour work. It will be 1 by 6. And next, B and C together fill the tank in 10 hours. So B plus C is 1 hour work. It will be 1 by 10. And then next we have A and C together fill the tank in 7.5 hours. So 7.5 it is nothing but it is 15 by 2. So A plus C fill the tank in 15 by 2 hours. So A plus C is 1 hour's work will be reciprocal of this. So it is 2 by 15. Now we can find A plus B plus C is 1 hour work. When we add all these three, when we add all these, there is A plus B plus C plus A plus C. A plus B plus C plus A plus C. All these 1 hour work. It will be the sum of all these 1 by 6 plus 1 by 10 plus 2 by 15. Now here we can see that it is 2 into A plus B plus C. Since we have 2A plus 2B plus 2C. So 2 times A plus B plus C is 1 hour work. Here the LCM is 30. So 5 plus 3 plus 4. So this is 12 by 30 or it is 2 by 5. So here we can see that 2 times A plus B plus C is 1 hour's work is 2 by 5. So A plus B plus C is 1 hour work will be 1 by 2 into 2 by 5. I am bringing this 2 to the other side. So it is 1 by 5. Hence A, B and C together will fill the tank in 5 hours. 5 hours. It is the reciprocal of this. So this is the first subdivision. First subdivision carries 2 marks. The second subdivision, in how much time will A separately fill the tank? So for that, let us find A's 1 hour work. A's 1 hour work will be A plus B plus C is 1 hour work minus B plus C is 1 hour work. So A plus B plus C is 1 hour work is 1 by 5. This is 1 by 5 minus B plus C is 1 hour work is 1 by 10. 1 by 10. So here LCM is 10. So 2 minus 1 which is 1 by 10. Therefore A will fill the tank in 10 hours. In 10 hours. Moving on to the third subdivision. In how much time will B separately fill the tank? So B's 1 hour work will be similar to the previous one. It will be A plus B plus C is 1 hour work minus A plus C is 1 hour work. So A plus B plus C is 1 hour work is 1 by 5. Then A plus C is 1 hour work is 2 by 15 minus 2 by 15. So here LCM is 15. 3 minus 2 by 15 it is 1 by 15. Therefore B will fill in 15 hours. 15 hours. And then the R part of the same C's 1 hour work will be C's 1 hour work will be A plus B plus C is 1 hour work 1 by 5 minus A plus B's 1 hour work 1 by 6. So this is 6 minus 5 by 30 which is 1 by 30. Therefore C will fill the tank in 30 hours. So these are the various times in which each of the pipes will fill the tank. Moving on to the next case study question. Read the following passage and answer the questions given below. The mark allocated is 1 plus 1 plus 2. Let X denote the number of hours a person watches television during a randomly selected day. The property that X can take the values Xi has the following form, where K is some unknown constant. So, property of X equal to Xi, it is equal to 0.2 if Xi is 0. It is equal to K into Xi if Xi is 1 or 2. It is equal to K into 5 minus Xi if Xi equal to 3. It is equal to 0 for any other value of Xi. So, we have various subdivisions. You have to find the value of K, then probability that a person watches 2 hours of television on a selected day, and then probability that a person watches at least 2 hours of television on a selected day, or probability that the person watches at most 2 hours of television on a selected day. So, based on the information which is given here, first let us find the value of K. So, we can draw a table like this with Xi and probability of Xi. So, the various values which Xi takes are 0, 1, 2, 3 and others. When Xi is 0, probability of Xi is 0.2. So, this is 0.2. When Xi is 1, it is K into Xi. So, it is K. Then when Xi is 2, it is K into Xi. So, it is 2K. Then when Xi is 3, it is K into 5 minus Xi. So, K into 5 minus 3, which is 2. So, this is K into 5 minus 3. So, it is again 2K. For other values of Xi, it is 0. And now we know that the sum of all these probabilities, it is equal to 1. If X is a random variable, then the sum of all these probabilities is equal to 1. So, summation probability of X equal to Xi is equal to 1 implies 0.2 plus K plus 2K plus 2K equal to 1. Or we have 5K equal to 1 minus 0.2, which is 0.8. 0.8 is nothing but it is 8 by 10, or it is 4 by 5. So, 5K is 4 by 5. K will be 4 by 5 into 5, which is 4 by 25. Therefore, K equal to 4 by 25. So, this is the value of K. Now, let us move on to the next subdivision. What is the probability that a person watches 2 hours of television on a selected day? So, for the second subdivision, it is probability of Xi is equal to 2. For the second subdivision, probability of Xi equal to 2 is 2K. So, probability of Xi equal to 2. It is equal to 2K. K we already got the value as 4 by 25. So, it is 2 into 4 by 25, which is 8 by 25. Next, we have the third subdivision, probability that the person watches at least 2 hours of television on a selected day. So, the third subdivision is probability of X greater than or equal to 2. So, it is probability of X equal to 2 and X equal to 3. So, probability of X equal to 2, it is 2K, and X equal to 3 is also 2K. So, this is 2K plus 2K, it is 4K. K we already found it is 4 by 25. So, this is 4 into 4 by 25, which is 16 by 25. The R part, what is the probability that the person watches at most 2 hours of television on a selected day? At most is probability of X less than or equal to 2. So, probability of X less than or equal to 2, it is 1 minus probability of X greater than 2, or it is 1 minus probability of X equal to 3. So, 1 minus probability of X equal to 3, it is 2K. because for other values of xi it is 0. So this is 1 minus 2k. So it is 1 minus k, it is here 2 into 4 by 25. So it is 1 minus 8 by 25, or it is 25 minus 8 by 25, which is 17 by 25. So probability that person watches at most 2 hours of television on a selected day, it is 17 by 25. So this is the next case study for 4 marks. Moving on to the last case study. When observed over a long period of time, a time series data can predict trend that can forecast increase or decrease or stagnation of a variable under consideration. Such analytical studies can benefit a business for forecasting or prediction of future estimated sales or production. The table below shows the welfare expenses in lakh rupees of steel industry during 2001 to 2005. Fit a straight line trend by the method of least squares and estimate the trend for the year 2008. So here we have various years. For various years, the welfare expenses are given. So first we have to fit a straight line trend by the method of least square, and then we have to estimate the trend for the year 2008. So here we can see that for various years from 2001, 2002 to 2005, the welfare expenses in lakh rupees is given. So we have to fit a straight line trend by the method of least square. So let us draw a table like this. The various years given are 2001, then 2, then 3, 4 and 5. And then the various values, welfare expenses, we take it as Y. 160, 185, 220, 300 and 500. So here the sum of all these values, summation Y, when we add all these, we get 1375. And next we can take excess. Here we can see that the number of years is 5, which is an odd number. So we can shift the origin by taking this 2003 as the middle year. So x is year minus 2003. So for 2003 this is 0, for 2002 it is minus 1, for 2001 it is 2001 minus 2003 minus 2. Then for 2004 it is 1. For 2005 it is 2. As a result we get the sum of all these values as 0. And next we have x square and then xy. So x square is square of each of these. So minus 2 whole square 4, minus 1 whole square 1, 0 square 0, 1 square 1, 2 square 4. Now the sum of all these is 10. And next we have xy, that is the product of these two columns. So 160 into minus 2 minus 320, 185 into minus 1 minus 185, then 0, then 300 into 1, 300, then 510 into 2, 1020. So when we add these two, this is 1320, and then when we add these two, it is minus 505. So 1320 minus 505. It is 815. So summation xy, it is 815. So now that we have got the values for all these, let us find the constants first. So A is given by sigma y upon n. Sigma y is 1375 upon n is 5 years. So this is equal to 275. And next B is sigma xy upon sigma x square. Sigma xy is here, it is 850 upon sigma x square is 10. So this is 81.5. So we can write the trend line given by y is equal to a plus b into x, or y is equal to 275 plus 81.5 into x. So this is the trend line which is required for this data. Now we have to estimate the trend for 2008. So for 2008, first let us find the value of x. X is 2008 minus 2003, which is 5. Therefore, YC will be 275 plus 81.5 into 5. In this x, let us substitute this 5 so that we can estimate the welfare expenses for 2008. So this is 275 plus 407.5. So when we add these two, we get 682.5 rupees lakhs. So this is the estimated value for welfare expenses for the year 2008. This is what we have to find. So here drawing the table carries 2 marks. Finding the value of A carries half mark. Finding the value of B carries half mark. And estimating the value for 2008. It carries 1 mark. A total of 4 marks for this question. Now moving on to the R part of the same question. I think it is a similar question from the CBSE Handbook from the chapter time series. The annual rainfall in millimeter was recorded in Chirapunji, Meghalaya. So for various years from 2001, 2002 till 2009, we have the data for rainfall given in millimeter. 1.2, 1.9, etc. 1.3. We have to determine the trend of rainfall by 3 years moving average, and we should also draw the moving averages graph. So let us draw a table like this first. We have year, and then Y is the data on rainfall, and then the next column is 3-year moving total, and the next column is 3-yearly moving average. So the data for various years are 1.2, 1.9, 2, 1.4, 2.1, 1.3, 1.8, 1.1 and 1.3. So first let us find the 3-year moving total. The 3-year moving total will be the sum of these 3 values, and we have to write it along 2002. So 1.2 plus 1.9 plus 2. So this is 5.1. And then the 3-yearly moving average will be 5.1 divided by 3, which is 1.7. Then for the next year, we have to add these 3. 1.9, 2 and 1.4. The sum is 5.3. Then the 3-yearly moving average is 5.3 divided by 3, 1.77. Then the 3-yearly moving total is 2 plus 1.4 plus 1.1. So it is 5.5. Then 5.5 divided by 3 is 1.83. Then for the next year, we have to add these 3 values. 1.4, 2.1, 1.3. The sum of these 3, it is 4.8. Divided by 3 is 1.6. And next we have the next 3 years, the sum of next 3 years data, 2.1, 1.3 and 1.8. When we add all these, we get 5.2 divided by 3 is 1.73. And next we have the sum of next 3 years, which is 1.3, 1.8 and 1.1. The sum of these 3 is 4.2. Divided by 3 is 1.4. And then we have the last 3 years moving total, 1.8, 1.1, 1.3. Again, when we add all these, we get 4.2. Divided by 3 is 1.4. So we got the 3-yearly moving total and 3-yearly moving average. Now we have to represent this on a graph. So let us take a graph sheet and have the x-axis and the y-axis. Now along the x-axis we have the years. So we have, this is 2001, 2002, then 2003, 2004. Like that we have to write till 2009. So this is year. And then along the y-axis, we have the data for rainfall in millimeter. So this is rainfall in millimeter. Okay. First, we have to plot the points for actual data. So for 2001, it is 1.2. This is 2001. So 2001, 1.2, it is somewhere here. And then for 2002, it is 1.9, somewhere here. For 2003, it is 2. And then for 2004, it is 1.4. Then for 2005, it is 2.1. Then for 2006, it is 1.3. Then for 2007, it is 1.8. 2008, it is 1.1. And 2009, it is 1.3. So here we have to join these points using a scale. So this is the actual data. And after this, we have to plot the points for 3-yearly moving average. We don't have any data for 2001, so we have to start with 2000. For 2002, it is 1.7. So 1.7, it is somewhere here. And then for 2003, it is 1.77, somewhere here. Then for 2004, it is 1.83, somewhere here. Then for 2005, it is 1.6. And then for 2006, it is 1.73. Then for 2007, it is 1.4. And for 2008 also, it is 1.4. So we have to differentiate the lines. So here, this straight line, this is actual data. We have to write this also. And then we can either use a blue pen and a pencil to differentiate these two. The blue pen can be used for actual data and a pencil for moving average, or vice versa, or we can use a dotted line, a straight line like this, and a dotted line for moving average. Since I have the option to use a different color, let me use a different color to differentiate these two. So this is 3-year moving average. So the dotted line represents 3-year moving average. So this is how you have to represent this on the graph. That is the 3 years moving average, it is represented on this moving averages graph. When we see the actual data, we do not get any meaningful idea. But when we see the 3-yearly moving average, we can note that there is a slightly downward trend over a period of. So here, drawing the table carries 1.5 marks, and then drawing the graph with all these written correctly, all these should be written. That is which line you are giving for actual data and which line is for moving average. All these should be written clearly. And drawing the graph carries 2.5 marks. It is better to write the values also. These values also we can write it here. So this is 1.2, then this is 1.9, then this is 2, and then 1.4, then 2.1, 1.3, 1.8, 1.1, and 1.3. Then for the moving average, the values are 1.7, 1.77, 1.83, 1.6, 1.73, 1.4 and 1.4. I hope this video was useful for you. With this, the sample paper solution for CBSE Class 12 Applied Mathematics for the academic session 2023 is done. In my previous videos, I have solved the other sections. I wish all the students all the best for all your exams. Thank you for watching.